Morning class. Okay, today we look at the Fourier series. Okay, Fourier series. So in the last class, we have learned what is a periodic function. Okay, so this is a periodic function. When you sketch this, graph from negative pi to 0, from negative pi to 0, you have negative 1. Okay, negative 1 is here. And in this interval from 0 to pi, okay, 0 to pi, you have plus 1. Okay, plus 1. Both are constant, so we have horizontal lines. Okay. Now from here, we know that the period is 2 pi. Okay, 2 pi means that from this negative pi to pi. Okay, from negative pi to pi, the distance is 2 pi. This is a period. Okay, period means this is one full cycle. Okay, one full cycle. So when we copy and then we paste it on the right and on the left, we have this graph of periodic functions. Okay. Now, what is that to do with the Fourier series with this periodic function? Okay. So actually, we can present this periodic function into Fourier series. Okay, this is a series. Okay, this one, this is a Fourier series. Because this is a series. Summation. Okay, summation. And odd means n is 1, 3, 5, 7, and so on. When n is 1, you have sine 1t over 1. Okay, sine 1t over 1 means sine t. When n is 3, you have sine 3t over 3. This one, sine 3t over 3. And when n is 5, you have sine 5t over 5. Okay, plus dot dot dot, that's mean, and so on. Okay, this is a series. This is a series. Okay, we still have a 4 or 5 here. This is a series. So if you use a software to sketch for this Fourier series, okay, let's say we use only the first 3 terms, okay, from the series. We use only these 3 terms multiplied to 4 or 5. You get this graph. You get this graph. This graph is sketched using only 3 terms. Okay, so if we use more terms, which is 6 terms, okay, if you use 6 terms, okay, that means 5, 7, 9, 11, okay, the 6 terms, then this is the graph. Okay, this is the graph with 6 terms. So if you use more terms, 12 terms, you get this. If you use 24 terms, okay, this is more like the horizontal line. Okay. So imagine if you use infinite terms, because this Fourier series, it is up to infinity. Okay, up to infinity. That means we have infinite terms. So if we use infinite terms to sketch for the graph, you will get this. Okay, you will get this because this will be horizontal line. When you have infinite terms, this will be horizontal line. So that's why negative 1, 1, negative 1, 1, which is same exactly as this. Okay. So means that if you sketch the Fourier series, okay, if you sketch this one using infinite terms, that means you will get the same graph as this periodic function. Okay. Basically, they are representing the same graph. This periodic function and this Fourier series are representing the same graph. Okay, so next we will look at how to present the periodic function into a Fourier series. Okay, into a Fourier series. So this is the formula for the Fourier series. Okay, this is called Fourier series. Okay, to get this Fourier series, we need the A0, AN, and VN. You have to find these 3 terms separately. So these are the formulas. Formulas will be given in the appendix of a final exam, because in every semester, in every year for this subject, there will be one question from Fourier series, this chapter. So formula will be given. So today we will look at the full range Fourier series, full range. Next week we will look at the half range. Okay. Okay. This one, the first example, sketch the graph of a function from -3 up to 3. Okay. So this is the periodic graph, periodic function. -1 up to 0. This one, in this interval, you have 2. And then from 0 up to 1, you have 3. 0 up to 1, you have 3. So this is one full cycle segment. Okay. And the period is 2. From -1 up to 1, the period is 2. Okay. 2 units of distance. So we copy this and then we paste it on the right and on the left, because it wants the graph from -3 up to 3. Okay. From -3 up to 3. So this is the graph. Then find for the Fourier series of this given periodic function. Okay, this periodic function is defined in the interval from -L up to L. From -L up to L. And this periodic function, we can also define the function in the interval from 0 up to 2L. Okay, see this one, 0 up to 2L. So that means the L is 1. 0 up to 2L. This is your 2L. That means L is 1. This is in the interval from -L to L. Okay, L is also 1. Okay, the L will be the same no matter you define the function in the interval from -L to L or 0 to 2L. Okay, because they are referring to the same graph. Okay, if you look at this one, 0 up to 1, you have 3. This one, 0 up to 1, you have 3. And 1 up to 2, you have 2. In this 1 up to 2, you have 2. So when you copy this one and then you copy paste, you still get the same graph from -infinity up to infinity. Okay, so there are 2 ways for us to define a periodic function. One is in the interval from -L to L. Another one is from 0 up to 2L. Okay. So based on this graph, okay, the ft is neither odd nor even, because it is not symmetrical about the y-axis or origin. Okay, this is neither odd nor even. So if the periodic function is neither odd nor even, we have to use the formula of full range Fourier series. Full range. So if it is odd or even, we will use half range. Okay. Of course, if it is odd or even, we can also use the full range formula. It's just that one of it, an or bn, it will be 0. Okay. You still can use, but normally, if it is odd or even, we will use the half range Fourier series, because half range we have one is cosine, another one is sine. Okay, that one we look at that in next week. Okay, today we just look at full range. Okay, so based on this periodic function, okay, and we have already identified the L as 1. Okay, L is 1. Okay, so there are 2 ways that you can identify the value of L. Okay, we need the value of L because from the formula, okay, we need the value of L. Okay, here. Okay, so first step, you need to identify the value of L. So there are 2 ways to find for the L. The first one is, okay, we know that this is a periodic function, okay, defined from -L up to L. So we know that L is 1. And another way is, we know that this is the period. Okay, this is period 2. And this P equals to 2L. P is always equals to 2L. So when you equal this 2 to 2L, L is 1. So there are 2 ways to identify the values, the value of L. After that, you just substitute the value L into the A0, okay, formula. Okay, this is the formula for A0. So we substitute L by 1. This is -1. Okay, but your function, you have 2 different functions in this interval and this interval. We want to integrate from -1 up to 1, but you have 2 different functions in these 2 different intervals. So that's why we have to break this integration into 2 parts. Okay, the first one is from -1 up to 0, you have 2. And from 0 up to 1, you have 3. We just break the integration into 2 parts accordingly, okay, based on the interval. Then you just integrate as usual, integrate 2 with respect to t. You get 2t. Okay, then -1 up to 0, and this is 3t from 0 up to 1. Okay, so just substitute 0 into t and then minus the substitution of -1 into t, and solve this as well, you get 5. Okay, solve as usual, you get 5. Next, we find for an. Okay, an, this is the formula for an. So you substitute the L value here, 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 and also here. When L is 1, okay, this one when L is 1, that means this angle will be n pi t. Okay, n pi t over 1 is n pi t. Okay, so since we are integrating from -1 up to 1, this one from -1 up to 1, -1 up to 1 with different functions. So we break this into 2 parts, where in the interval from -1 up to 0, you have 2. So your ft is 2. 2 cos n pi t. And in another interval, 0 up to 1, you have 3. So 3 cos n pi t, you get this. Okay, then integrate. Just integrate directly because we have only one t, okay, one function of t. Okay, so to factorize, integrate cos, you get sine with the same angle n pi t over n pi. Okay, over n pi. You just differentiate n pi t with respect to t, you get n pi. Okay, then -1 up to 0. Same goes to this one. You integrate, you get the same function, get 0 up to 1. Okay, now we will substitute the 0 into t. So sine 0 is 0. Then we substitute -1 into t. You have negative n pi. Okay, negative n pi. That means sine negative n pi. Sine negative n pi equals to negative sine n pi. For sine function, we can take out the minus from the angle, right? Sine negative theta equals to negative sine theta. Okay, sine negative theta equals to negative sine theta. So this one, negative n pi, the negative, we can bring it out so that we have minus sine n pi. Still sine n pi, remember this one, sine n pi is forever 0. 0, okay? That's why you get 0, this one. Okay, next one, 1, when you substitute 1 into this t, sine n pi is 0. Okay, minus 0, substitute into t, sine 0, still 0. So 0 minus 0, you get 0. So in the end, your an is 0. Okay, next one, we look at Bn. This is the formula for Bn. Okay, so you substitute 1 into this L, 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 and L here, you get this. Okay, then break this integration into 2 parts. Okay, where the first one is 2, the second one is 3 for ft. Okay, so integrate as usual, integrate sine, you get negative cos n pi t over n pi. Okay, same goes to this one. Okay. Then 0, when you substitute 0 into this t, cos 0 is 1. Okay, but before that, I factorize -1 over n pi first. Okay, take out the -1 over n pi to outside. So you have -2 over n pi. Then 0 into t, cos 0 is 1. Okay, minus -1 you put into t, you have cos negative n pi. Cos negative n pi equals to cos n pi. So you have cos n pi. Okay, so similar to the second term. Okay, then simplify, you get this, and cos n pi is this function. Okay, so there are 2 things you need to remember for Fourier series. Sine n pi is 0. Cos n pi is -1 to the power of n. Okay, this one, after you get all the A0, AN, BN, substitute them into the formula, Okay, but an just now is 0, so this term is gone. You have only this. So Bn is this one. Bn sine and phi t. L is 1. Okay, Bn sine and phi t. You substitute this Bn, then this is the final solution. Okay, for the substitution part, okay, this one I will repeat on the whiteboard. The an, I repeat the an just now. Okay, repeat the substitution of t. Okay, from the example just now, the an. Okay, 0 into this t, so sine 0. Okay, you get 0. Okay, sine 0 is 0. Minus -1, when you substitute into this, you get a sine negative n5, right? Over n5. You get this one. Right? Plus 3, okay, 1 into this t, you have sine n5 over n5. Minus 0 into t, you have sine 0, which is 0. Okay, because we know that sine 0 is 0. So now if you look at this one, sine negative n5. Sine negative theta equals to negative sine theta. Cos negative theta equals to cos theta. Okay, based on this one. Based on this one. That means this one equals to negative sine n5. Right? This is actually, we can bring out the negative just like this one. For sine function, the negative from the angle, we can bring it out. Like this. So this is negative sine n5. Negative sine n5, but sine n5 is 0. That's why this is 0. Okay, 0 over n5 still, the whole thing is 0. Okay, plus this one, sine n5 is 0. 0 over n5, 0. Okay, that's why you get 0 for an. Okay, so this is for example just now. Any questions? If you look at the Vn just now, okay, Vn. Vn. Okay. Cosine. Done. Okay. And we look at the one for Vn. Okay, for substitution part. Okay, before we substitute the value into t, we can factorize the -1 over n5. Bring it out, -2 over n5. Okay, meaning that you just substitute t into value into this t later. The same goes to this one. -3 over n5 cos n pi t 0 up to 1. Okay, we factorize the constant. We factorize the constant before we do the substitution. Will be simpler. Okay, now when 0 substituted into this t, cos 0 is 1. Cos 0 is 1. Minus -1 is substituted into here. What do you have? Cos negative n pi, right? Negative n pi. Okay, 1 into t cos n pi. Minus 0 into t cos 0 is 1. Okay, so this one cos negative n pi. What is cos negative n pi? Cos n pi. Okay, cos n pi. This is cos n pi. So we can expand. We expand. Plus 2 over n pi. This is cos n pi now. Cos n pi. Okay, minus 3 over n pi cos n pi plus 3 over n pi. Okay, so we simplify. -2 plus 3. Okay, that means 3 minus 2, 1 over n pi. 2 minus 3 minus 1 over n pi cos n pi. Same function. So this one, we can factorize the 1 over n pi. Factorize 1 over n pi. That means 1 minus cos n pi. Okay, and lastly, we will substitute the cos n pi as -1 to the power of n. This one, cos n pi. We substitute cos n pi as -1 to the power of n. So this is your Vn. Any questions? At this moment, I hope you understand every single step on how to get the an, the Vn from the integration and also the substitution. Okay, substitution of the values of t. Okay, once you have obtained the A naught, AN, BN, you just put them into the formula to get the final answer. Okay, so this is the final answer for the Fourier series. Okay, and next we look at the second example. Okay, sketch the graph from -3 pi up to 3 pi, -3 pi up to 3 pi for this periodic function. Okay, so this one from -pi up to 0. Okay, this one -pi up to 0, you have 0. 0 is a constant, so horizontal line. 0 up to pi, we have t. 0 up to pi, we have t. So if this is pi, this means this is also pi, okay, because this is t. Okay, something like y equals to x. Okay. So from this graph, okay, we know that this is not, this is neither odd nor even. Okay, neither odd nor even. Okay, so we will use the full range formula. Okay, full range formula. Okay. To find for the Fourier series, then we will choose an appropriate value for t to reduce the sum. Okay, we want to find out the sum of this series based on the Fourier series. Okay, so what is the L from this? Okay, what is the L from this periodic function? Your L is pi. This function is defined from from negative L up to L. So L is pi. Or you equal 2 pi to 2L. Okay, equal the period to 2L, so L is pi. Okay, and this function is actually same with this one. It's just that this is defined in the interval from 0 up to 2L. Okay, 0 up to 2L. That means this function, it treats this as a full cycle segment. Then you copy this one and you paste it here. Okay, but since it wants this from -3 pi up to 3 pi, we just take the part of -3 pi up to 3 pi. Okay, no matter the function is given as this one or this one, the graph is still the same. From -3 pi up to 3 pi, this is the one. Okay, then L is pi. We will start to find for the A naught. Okay, so substitute L by pi. Okay, you will get this one. Okay, -pi up to pi. But from -pi up to pi, we have two different functions. So we will break this interval. Okay, break this integral into two parts. Okay, where the first part, this integration of 0. Okay, this is definite integral. Definite integral means you are given the limits. When you are given the limits and you are integrating 0, okay, that means the answer is 0. If you are not given, if these are not given, limits are not given, if you are integrating 0 with respect to a variable, that means you will get a constant c. Okay, so this part is 0. So we just need to solve for this. So integrate t, we get t squared over 2. Okay, 0 up to pi. But do not forget about this 1 over pi in front. Okay, so just substitute pi and then 0 into t to get the final answer. Okay, next, AN. AN. Substitute pi into all this L. Okay, here. When L is pi, you can cancel out the pi here with this pi. So your angle will be NT. Okay, the angle will be NT only. You can cancel out because L is pi. Pi cancel out with pi. Okay, so this one, from -pi up to pi, we will break this integration into two parts. Okay, the first function ft is 0. Another one is t. Okay, so you have this line. So this is 0, and this one we need to use tabular method. T cos and t. T cos and t. So differentiate until you get 0. And this one, integrate twice. Okay. Then you will get this line through the tabular method. Okay. Then pi. We substitute pi into t. Okay, into t. So sine and pi is 0. Okay, sine and pi is 0. And then this pi into this t, you have cos and pi. 1 over n squared cos and pi, this term. Okay, minus, now 0, substitute into this t and this t. So this is 0. And cos 0 is 1. So we have 1 over n squared, this term. Okay, and finally, factorize the 1 over n squared, you get cos n pi minus 1. And this is your cos n pi. Okay, this is similar, okay, similar to the previous example. Okay. So far, any questions? Okay, next we look at Bn. Okay, Bn is similar to An, it's just that here is sine instead of cos. Okay, instead of cos just now. So you substitute L by pi, separate the integration into 2 parts. This will be 0, and we integrate this using tabular method. Okay, so when you get this line, you substitute pi into this t. So negative pi over n cos n pi. You have this line. You have this term. Pi into this t, sine n pi is 0. Okay, then 0 into this t and this t. When t is 0, that means this is 0. Sine 0 is also 0. That's why you have only one term. Okay, cancel out the pi. Okay, so you have negative 1 over n. This one, negative 1 over n. Cos n pi is this function. Okay, and you can leave your answer in this. Okay, you can leave this as your Bn. But if you know how to combine, you can combine the negative into one negative. Okay. The first negative 1 is negative 1 to the power of 1. This is negative 1 to the power of n. So you combine the power of 1 and power of n. You combine the two negative 1 into 1. So you get this. This is your Bn. Okay. But you can leave your Bn as this. Okay. Then finally we combine. We substitute all the A0, An, Bn into the formula, then you will get the Fourier series. Any questions? Okay, next we need to select or choose. We need to choose a suitable value for t to deduce the sum of this. Okay. So if you look at this one, you compare to this one and also this one. So what do you think? This comes from this one or this one? The coefficient of cos or coefficient of sine? You look at these few values.
Oh.
It comes from cos because of this n squared. Okay, because of this n squared, you have 3 squared, 5 squared, 7 squared. This one without square. So now we need to choose a suitable value of t in such a way this term is 0, this term is non-zero. Okay, so the suitable value would be 0 because sine 0 is 0, sine 0 is 0, cos 0 is 1. Is 1. So we have only this one. That's mean this part. Okay. When t is 0, we have only this part. Okay, so on the left, we have f0. T is 0, so f0. So how do we know f0 is 0? Answer is already given. Why f0 equals to 0? When t is 0, your ft is 0. Okay? When t is 0, your ft is 0. That's why this is 0. Okay, now we substitute the t equals to 0 into this of equation. So on the left, you have f0, f0. So this one, f0 equals to this part. Okay, this part, because cos 0 is 1, sin 0 is 0. So this term is already gone. Okay, so from here, f0 is 0. And then this one, we need to expand. Okay, n is 1 up to infinity. It means that n is 1, 2, 3, and so on up to infinity. Okay, we start from n equals to 1. When n is 1, you have 1 square here. 1 over 1 square pi. That means 1 over pi. Okay, this one 1 over pi. And when n is 1, you have negative 1. Okay, negative 1 minus 1, you have negative 2. When n is 2, okay, when n is 2, you look at this part first. When n is 2, negative 1 squared, you get 1. Okay, negative 1 squared, you get 1. 1 minus 1 is 0. So when this n is even number, 2, 4, 6, and so on, you get 0. Okay, it is non-zero only when n is odd number. Okay, so next one, n is 3. When n is 3, you have 1 over 3 square pi, this one. And this is negative 2, because negative 1 to the power of 3 is negative 1. Negative 1 minus 1, you get negative 2. Okay, and then when n is even, you get 0. The next n is 5. Okay, 5. That's why you get 1 over 5 square pi. And this one, when this is power of 5, you get negative 1. Negative 1 minus 1, negative 2. Okay, so similar to n equals to 7. Okay, once you get this, okay, we simplify. Okay, we simplify. So from each of these non-zero terms, there is a negative 2. You can factorize the negative 2. And also, there is a 1 over 5. Okay, 1 over 5, 1 over 5, 1 over 5. So we factorize the negative 2 over 5. Okay, we factorize negative 2 over 5. So we have this minus 2 over 5. Okay, so what is left here? This is 1. This is 1 over 3 squared. 1 over 5 squared. 1 over 7 squared. Okay, this is how you get this line. And finally, we want only this. Okay, we want only this. So you move this term to the left, and you move the 2 over pi to the right. Then you get this. Okay, this one I write on the board. Okay, so from here, we want to find the sum of this. Okay, so we move this term to the left. So minus, it will be plus. Equals to pi over 4. Then we want only this. So pi goes up, 2 goes down, then you get this. Okay. Any questions? Huh? Any questions? Okay, now we proceed to the exercise. Okay, try this one. Done? Well, it's time for your attendance. We sketch the graph of the function from negative 3 up to 3. From negative 3 up to 3. The graph. Okay. From negative 1 up to 0, you have negative 1. Negative 1 is constant on the line. And from 0 to 1, okay. This is one full cycle with period of 2. Okay, period of 2. So this is one full cycle. Copy paste. Copy paste on the left, on the right. That means you copy the graph in this interval and paste it into this interval and also this interval. Okay, what is the L? L is 1. Okay, 1 either this one negative L to L or equals the 2 to 2L. Then your L is 1. That from A naught. Okay, this is the formula for A naught. So you substitute the L by 1. Okay, substitute L by 1, then it extract the integration into 2. Negative L to L. When zero, then y. What is an A naught? Have you got your A naught? Your A naught should be negative half. Negative one. Together, C squared over 2. Here. 0 into T, 0. And then minus negative, so you get a plus. Negative 1 into T, you have negative 1. Okay, plus 1 into T, you have 1 over 2. Minus 0 into T, 0. That's why you get negative half. Then AN. When L is 1, so this angle will be n pi t. Okay, so break this into 2. For the first term, you just integrate directly, but for the second term, t cos and phi t, you have to use calculus. Okay. So integrate cos, okay, factorize the negative first, negative. Integrate cos, you get a sine and phi t over and phi. And that one you have to cos and phi. Use calculus. Integrate cos, you get a positive sign and phi t over and phi. When you integrate once again, integrate sign, you get negative cos and phi t over one more and phi. Then you get n squared phi squared. Now we look at the substitution of t values. Okay. 0 into t. Okay, 0 into t. So sine 0 is 0 minus, okay, negative 1 into this t. negative 1 into this t. That means negative n pi. Sine negative n pi is negative sine n pi, which is 0. Sine n pi is 0. Okay. So negative sine n pi is still 0. Yes. 1 into this t, sine n pi, 0. 1 into this t, you have cos n pi. Cos n pi. Minus 0 into this t and this t, 0. Okay, no matter it is sine 0 or 0 multiplied to the whole function, you get 0. Plus 0 into this t, cos 0 is 1. Okay, simplify. Simplify, your an will be this one. Factorize 1 over n squared pi squared and change the cos n pi into negative 1 to the power of n. Then you get your an. This is your an. Okay, next Vn. Okay, substitute the L by 1. Separate one and t. Similar to the an. This one integrate directly. This one tabular method. Any questions? Integrate negative sign, we get a point in cos. Have you ever met that? Sine of pi t. Integrate sine, get a negative cos and pi t. Integrate negative cos, get negative sine. Now we substitute the values into t. So 0 into this t, just mean cos 0. 1. Minus -1 into this t, we have cos negative and pi. Cos negative and pi is also cos and pi. Yeah, put a negative first. Yeah, put a negative first. Easy compute doing that. Okay, -1, and you get this negative and pi. Plus now 1 into this t and this t. -1 over m pi cos and pi. T is 1. And now when this t is 1, sine and pi is 0. 0 into this t and also this t, you get 0. 0 into this t and also this t. When this t is 0, that means everything is 0. Plus 0 into this t 0. Okay. Simplify. Okay, now cos negative n pi, you can write cos n pi. Two same functions. Okay, so -1, you get -2. Oh, sorry, this one, when t is 0, you have cos 0 is 1 over n pi. This one should be 1 over n pi. And factorize the 1 over n pi. Can you hear? So your Vn factorize 1 over n pi. You have 1 minus 2. 1 minus 2 cos n pi is -1 to the power of n. Okay, so now you have got your A naught, An, Bn. Substitute all this into the Fourier series formula. Now, E is A naught. A naught, this now A naught is -half. -half divided by 2, -1 over 4. Your An just now. That is 1, so cos n pi t plus Bn sin n pi t. Okay, any questions? No questions? We look at question number 2. Sketch the graph of the function from -6 to 6. From -6 to 6. Two and 1. 2 and 1. Copy paste. And what is the L? What is the L for a number 2? What is the L? 2. Yes, from negative L up to L. So if L is 2, then I'll substitute 2 into the L of A naught. Then Write the integration into 2.
Yeah, that's too many. You can repeat something in the top.
Where's the A naught? Let me get the A naught. Your A naught should be 3. Okay. 0 into T, you get 0. Minus -2 into T, you get -4. -4, that means plus 4. Okay, plus, this is 2 minus 0. So 4 plus 2, 6. 6 over 2, 3. Okay, when L is 2, your angle will be n pi t over 2. There's only one function in t, so you just integrate directly. Integrate cos, okay, factorize 2 first. Integrate cos, you get sine n pi t over 2 over n pi over 2. Okay, same goes to this one. Okay, over n pi over 2. Okay, that means this 2, we can bring it up. So we have 2, 2, 4. 4 over n pi. Sine n pi t over 2. Then goes to this one. This 2, we bring it up. Yeah, 2 over n pi. Sine n pi t over 2. Okay, now we substitute the values into t. So when 0, okay, you put into this t, sine 0 is 0. Okay, minus, okay, minus -2. When you put a -2 here, when t is -2, cancel out the 2. Okay, cancel out the 2, and you have negative n pi. Sine negative n pi is also 0. Okay, this one. 2, we put into this t, cancel out the 2, sine n pi is 0. Then when this 0 we put into this t, sine 0 is also 0. So your ABN is 0. Okay, then BN. Two and one. Okay, the great sign, we get a negative cos. Negative 2 cos and 5t over 2 over and 5 over 2. Take the 2 up. Okay, and we look at the substitution of t values. 0 into this t, cos 0 is 1. Minus, okay, negative 2 into this, cancel out the 2. You still have a negative here, but the cos negative and pi, same as the cos and pi. Okay, so minus, we have plus 4 over and pi, cos negative and pi. Okay, minus 2 into this t, cancel out the 2, you have cos and pi. Then 0 into this t, you have cos 0, which is 1. Okay, 1. Factorize, can factorize the minus, then I just substitute the 2 and 0 into this function. Two minus 4 minus 2 over n pi. 4 minus 2, you have a plus 2 over n pi, cos n pi. Okay. Factorize the 2 over n pi. Okay, but we can cancel out the 2 with this 2. So you will have 1 over n pi. Okay, negative 1 plus cos n pi. Which is negative 1 over n minus 1. And just now is 0. So it only be n. Okay, any questions? Okay, this is full range Fourier series, and we used to find for the periodic function, which is neither odd nor even. Okay, next week we look at the one for odd and even periodic function. Maybe we do some extension, okay, odd extension, even extension, okay, to get the Fourier series. Okay, this week I found that quite a number of students joined online class. Okay, but I just take that maybe this week is a midterm week. Okay, so many students they want to just stay in the hostel to do revision. Okay, this is what I think. Okay, but next week I hope everything will go back to normal, because when there are a lot of students join online class, I have to squeeze my screen, my whiteboard screen, to a smaller one, because when a lot of students join online class, the screen will be smaller. Later, the recording will be can't get to see part of the words. That's why I need to keep adjusting the whiteboard. Okay, so next week I hope everything go back to the normal. Okay, so I'll see you next week. Okay, for the half range audience unit. Yeah.